Hi guys, good morning to one and all. So my name is Dr. Shanmugan. As working assistant professor in physics department, Vijayawada campus. Today discuss about solar cell. Okay, that solar cell already you know. Okay, it is form of a photo cell. It is short meaning PV. Okay, the PV you know that is that convert to the electrical energy. So that is short time you can tell it here solar cell. Okay, it is defined a device whose electrical characteristics such as a current, voltage of resistance vary but exposed to lights. Individual solar cell device are of often the electrical building bulbs of a solar photovoltaic model, no collectively of a solar panels. The solar cell also called photovoltaic, any device that directly converts the energy of light into electrical energy through the photovoltaic effect. The overlapping majority of solar cell are fabricated from silicon with increasing efficiency and lowering cost as a material range from amorphous, that is you can tell it here non-crystalline to polycrystalline or to crystalline single crystal silicon forms. Unlike batteries or fossil fuels, solar cell do not utilize chemical reactions or require fuel to produce electric power, and unlike electric generators, they do not have any moving part. Main principle of the solar cell, you know, the solar cell, yes, no, the photovoltaic cell or PV cell is defined as a electrical device that convert light energy into electrical energy through the photovoltaic effect. A solar cell is basically a PN junction diode. Solar cell or form of photo cell defined as a device whose electrical characteristics such as current, voltage or resistance vary when exposed to light. Individual solar cells can be combined to form of models commonly known as a solar panel. The common solar cell junction silicon solar cell can be produced a maximum open circuit voltage of an approximately that values of 0.5 to 0.6 volt. If itself this is not much, but remaining these solar cells are dimming. When combined into large solar panel, considerable amount of renewable energy can be generated. So these all are very important the solar cell. So now you can go for here few our subject. We are all are engineering BTech level. For you can study for the various department. One of the backbone physics. So that physics based on your syllabuses you can study for here. Applied physics, that the course code is SE PH not 9. So that one you can consider for our physics lab, and the implementation for the few understanding for our KLF rules. So that rules you can follow in the here given understanding, derive, demonstration. After then you can solar cell how you can apply for the energy level. After then black surface how you can attract for the black body radiation also you can consider. After then total amount of energy you can consider the energy Einstein theory also you can consider for the here. So many application how you can implement it for the solar cell production. The production after that how you can getting for the potential force derivation. Then derivation you can combination you will get it the simple telling to you recombination process of the solar cell. That all here given the here as per learning. After then you can consider for our lab solar cell aim. First of all you can understand the aim. That aim you know the draw solar cell characteristics and to determine the fill factor of the solar cell. Okay, so this is a aim. After then you can use it for the here apparatus. That is you can tell it here solar cell, multimeter and voltmeter, variable load, key and lamp and circuit. These all are you can use it for the here apparatus. Okay, so after then you can go for the here before you can consider for the here BN junction. That PN junction before how you can convert for the electricity. You know how to solar cell produce electricity. Solar cells are the device for converting light into electricity. The primary element is often a semiconductor which absorb light to produce carriers of electric charge. An applied electric field can then sweep this carrier out of the semiconductor, thus producing an electrical current. Already you know. Okay, so that is after then how you can constructions of the solar cell. That solar cell is basically a PN junction. Although its construction it is a little bit different form of conventional PN junction diodes. A very thin layer P type semiconductor is a grow on a relatively thinner N type semiconductor. When then applied the few thinner electrolytes, the doped of the material, you can telling the here P type semiconductor layer. Here you can telling the here P junction and N type silicon doped. After then unstromy and amorphous material you can adding. After that you will get it here more electric charge. That charge you can telling here. You can already the 12th level you have studied that principle of the electrode do not absorb light. To reach the thin p-type layer, just below the p-type layer, there is a you can tell it here PN junction. We also provide a current collecting electrode at the bottom of the N-type layer. We encapsulated to the entire assembly by thin glass to produce the solar cell from any mechanical shock. Okay, so that material you can know that is here in this segmented diagram given that here BN junction and the PN junction process. After then you can tell the here working principle of solar cell. When light reach the PN junction, the light photons can be easily enter to the junction through very thin PV types of layer. The light energy in the form of photon supplies sufficient energy to the junction to create a number of electron hole pair. This instant light breaks the thermal equilibrium condition of the junction. The free electron in the duplications regions can quickly come to the N-type side of the junction. Similarly, the hole in the depletion can quickly come to the P-type side of the junction once the newly credited free electron come to the N-type side. Cannot further cross the junction because of barrier potential of junction. Similarly, the newly credited holds one junction or concentrations of holes carrier more of another side. That is the P-type side of the junction. The PN junction will behave like a small battery cell. A voltage is set up which is known a photovoltaic. If we connect a small load across the junction, there will be tiny current flowing through it. The bulk of the energy convert is composite of P-type material. Only a front surface layer of the warp has N-type conductivity. The N layer is called emitter. The P region called is base. When forming such as called PN junction diode structure. So electrical form of the emitter diffuse instantaneously into the base and the poles from the PN region diffuse into the emitter. This is due to the fact of the emitter contains a very high concentration of electrons compared to the base, whereas the basis is rich in holes. The diffusion in charge carrier lead to the build-up of a electric field, resulting internal voltage in the function of PN junction to under equilibrium condition. the electric force due to the field comparable to the force driving the diffusion. This no electric current flow. This is main part of the few point I share to you. So you can gain for that your project level or your engineering level and benefit the society level. You can utilize for the solar cell application. The current size generated by the cell in short circuit depend upon the incident light intensity and the energy spectrum. The photo current is related to incident spectrum by the quantum efficiency of the cell. When a load is present, a potential difference is decreased direction to photo current. As the load resistance increased, the potential difference increases and net current decreases until the photo current and the dark current exactly cancel out. The potential difference at the point is called open circuit voltage. Fourth point is, at some point before the open circuit voltage is reached, the current voltage produced is a maximum. The cell should operate when the load resistance